Today we are going to see density of states, density of energy states. Definition: the number of available energy states per unit volume in an energy interval E and E plus dE. That is, ஒரு energy interval E and E plus dE அப்படின்ற energy interval. அந்த energy interval எவ்வளவு number of energy states are available in a unit volume, that is defined as density of states. It is denoted by Z of E dE. எப்படி சொல்றோம்? Z of E dE அப்படின்னு எழுதிருக்கோம். So Z of E dE is equal to number of available energy states in an interval E and E plus dE, and it is represented by N of E dE. N of E dE அப்படின்னு இதை சொல்லுவோம். Divided by per unit volume னு சொல்லிருக்கோம். So divided by volume of the metal piece, capital V. So this is the definition: number of available energy states in an energy interval E and E plus dE per unit volume. Okay, so this is our definition. Now suppose we have a solid, say made up of n atoms, capital number of n atoms, then we would say that there are 2n states for the electrons to occupy. That is 2n states. N atoms na n states tha irukkum, ana n atoms we have 2n number of states to accommodate the plus half and minus half spin of the electrons. So rendu plus half ku undu minus half ku undu, therefore 2n number of states. N atoms is equivalent to or will be having n orbitals also having 2n states. Nama simple eduthukalam, n atoms அப்படின்னா there will be 2n states for electrons to occupy. Right? Now we go to the derivation part. Now let us consider a solid metal. Consider a solid metal. Consider a solid metal in a uniform potential, right? In a uniform potential. This uniform potential may be zero potential also. So zero potential is the simplest case. Zero is also a constant. So zero potential is the simplest case. So we consider this simplest case. Also for simplicity, we consider a cubical lattice of side A, of side length A. Cubical lattice means cubical metal, alright, cubical metal piece. Okay. So we consider these two things. Potential is zero and cubical lattice of side A. We know that in three-dimensional potential box, we know that E, energy, is given by the expression n square h square divided by 8ma square. So this we know from the three-dimensional potential box. Schrodinger's equation application, one-dimensional box, two-dimensional box, three-dimensional box we have studied. and in the three-dimensional box it is given by n square is equal to h square, sorry, E is equal to n square h square by 8m a square. We consider this equation as a, where n is also, or n squared, where n square is equal to nx square plus ny square plus nz square, right? So what is nx, ny, nz? It is the quantum numbers along the x, y and z axis respectively. We are going to draw this diagram also, right? So n square is equal to nx square plus ny square plus nz square, and nx, ny, nz are all quantum numbers. Right. We construct a quantum space. Now we construct an imaginary quantum space that is a sphere, a quantum space that is a sphere as shown in the diagram. Where is the diagram? Diagram we have seen in the beginning itself, right? So this is the diagram. So we have constructed a quantum space that is an imaginary sphere of radius n and radius n plus dn. What is n? N is the quantum number, and the quantum number n is made up of nx, ny and nz. We know that n square is equal to nx square plus ny square plus nz square. So with this arrangement we have drawn a sphere, a quantum sphere, an imaginary sphere of radius n and n plus dn to represent the energy state E and E plus dE as shown in the figure. Suppose this is the sphere for with radius n. The surface of the sphere is going to represent the energy E. The surface is going to have energy E, and the surface of the sphere n plus dn is going to have an energy E plus dE. So small increment in energy for a small increment in radius, right? Okay, this is the arrangement. Now, for larger values of n, now let us come to the derivation. For larger values of n, we say that the energy states are continuous. Energy states are continuous. For example, we have seen if there are n atoms, we have seen here, right? If there are n atoms, there are 2n states. Suppose this n is huge. If n is huge, means to accommodate these 2n states, the energy bands become continuous. Energy states become a band. They become continuous. So that is what we are reiterating once again. If for larger values of n, we say that the energy states are continuous, right? Therefore, if the states are continuous, then we can definitely say that each point in this volume, that volume of the sphere which we have constructed, right? In this volume represent an energy state, Each point represent an energy state. இப்போ இதை தமிழில் சொல்லணும் அப்படின்னா நம்ம சொல்கிற மாதிரி எவ்வளவு வால்யூமோ அவ்வளவு energy state. Blow volume of energy states. So this is what we mean by this. Each point in this volume is going to represent an energy state. Right? Blow volume of energy states. Therefore, the number of energy states corresponding to E, therefore number of energy states corresponding to energy E is equal to 4 by 3 pi n cube volume, right? So volume of the sphere with radius n, இல்லையா, அதில் எவ்வளோ வால்யூமோ அவ்வளோ ஸ்டேட்ஸ் இருக்கும். therefore number of energy states corresponding to energy E is 4 by 3 pi n cube, right? Okay, but இதில் ஒரு கண்டிஷன் போடணும். but n square is equal to nx square plus ny square plus nz square. All these should be positive. All are positive integers இருக்கணும். All are positive integers only. இப்போ இது எங்க இருக்கும் அப்படின்னு பார்த்தோம்னா 1/8 of the volume தான் இருக்கும். எப்படி நம்ம ஃபர்ஸ்ட் குவாட்ரண்ட் இப்போ trigonometry படிக்கும்போது ஃபர்ஸ்ட் குவாட்ரண்ட் இஸ் ஆல் பாசிட்டிவ்னு சொல்லுவோமோ அதே மாதிரி அது 2Dல. இப்போ இது 3 டைமென்ஷன்ல பார்க்கும்போது 1/8 அங்க 1/4 இங்க வந்து 1/8 of the volumeல தான் all these three values will be positive. nx, ny, nz will be positive only in the 1/8 of the entire volume. Therefore we consider only those states. Therefore the number of energy states corresponding to energy E is equal to 1/8 of this volume, 4 by 3 pi n cube, right? Because we have to consider only the first octant, 1/8 of the volume. அங்க quadrant னு சொல்லுவோம், இங்க octant, first octantல இருக்கிறது மட்டும்தான் nx, ny, nz will be positive. Therefore 1/8 into 4 by 3 pi n cube, that is equal to, இது என்ன வரும், 4 னு 2, இது அடிச்சோம்னா 2 ஆகுங்க, அப்போ 6, 1/6 pi n cube. So for 1/6 pi n cube. So this is the equation number 1. Let this be equation number 1. Similarly, number of energy states in the energy E plus dE என்னவா இருக்கும்? Similarly, the number of energy states corresponding to E plus dE is equal to என்னவா இருக்கும்? ஒண்ணுமே இல்லை, இதே தான் இருக்கும். ஆனால் என்னுக்கு பதிலாக என்ன இருக்கும்? n plus dn ரேடியஸ் இல்லையா, அடுத்த ரேடியஸ். ஸோ அடுத்த ரேடியஸில் இருக்கிற சர்ஃபேஸ் நம்ம போட்டோம் இல்லையா, ஒரு ஸ்பியர் n plus dn ரேடியஸோட ஒரு ஸ்பியர் போட்டோம். அந்த ஸ்பியரில் இருக்கிற சர்ஃபேஸில் இருக்கிற எனர்ஜி E plus dE. Therefore we write it as 1/6 pi n plus dn the whole cube. அப்படியே இந்த ஈக்குவேஷன் அப்படியே மேட்ச் பண்ணிக்கலாம். 1/6 pi n plus d. So let this be equation number 2.